where data meets intelligence, focusing on how AI is being embedded directly into mission-critical data systems. Our speaker, ladies and gentlemen, is Tirthankar Lahiri, Senior Vice President, Mission Critical Data and AI Engines at Oracle America. He leads the team responsible for building the core data platform that powers some of the world's largest enterprises. Tirthankar has 30 years of experience in database industry, and he has worked on variety of areas such as performance, scalability, manageability, caching, in-memory, architectures, and developer-focused functionality. Please join me in welcoming on the stage Tirthankar Lahiri. Come on, ladies and gentlemen, let's have a round of applause for Tirthankar.
Thank you, thank you.
Welcome.
Well, all right, great, wonderful. I have 7 extra minutes. I have a lot of slides. I have enough for 2 hours of presentation, actually, in this content. It really depends on how much you would want to hear about this stuff. And the next speaker is a friend of mine, so I'd like to keep him as a friend. So I'll try to finish on time, but I'm going to burn my entire slot in the deep, so just be aware. You won't get extra time. I'm going to take it. Okay, so let's talk about AI for data and how we bring intelligence to data. It's a match made in heaven. And I'll give you some tips and pointers about surviving this really exciting transformation in technology. So AI is a thing. It's more than a thing. It's changing everything, as you all know. And it's not something that you can sit out. There are some technology trends you can say, let's wait to see if it happens or not. This one, you can't wait. You have to respond to it now. The quote that I like the best that I've heard about AI, there's a lot of doomsayers say AI will just wipe out the civilization. It'll replace all humans. I don't buy all of that, but this, I think, is really true. That AI won't replace humans, but humans with AI will replace humans without AI. That is going to happen. And the same thing is true for enterprises. Enterprises with AI will destroy enterprises without AI. That's without a doubt. So how do you address that? The key thing to do is you have to transform yourself and your enterprise into being an AI leader. And to use AI for what it's good for, to deliver insights, innovations, productivity, before your competitors. In this race, there's no second place. You've got to be the winner to remain relevant in the future. So this is, why, this is such an important, monumental revolution. The good thing is, in Oracle, we have AI for data that gives you the tools to do exactly that. And hopefully you appreciate that what we have done is actually very simple. It's very easy to learn and very easy to use. Doesn't require a huge amount of expertise to understand and deploy. Because what we have done is taken an approach which I think should appeal to customers who think strategically. Folks who understand that gluing many products together leads to endless complexity and cost. It's a never-ending chase for complexity. And customers who believe that open standards are essential for creating a competitive ecosystem that benefits everyone. Oracle Database has a converged architecture that is based on open standards with best-of-breed support for all workloads and data types. And we are extending the same strategy to AI for data. We believe that AI and data have to be architected together. AI and data, AI and app dev, as well as AI and open standards. So let's talk about AI and data being architected together. So this is manifested in our latest release, which is Oracle Database 26 AI, which is the world's first AI-native enterprise database with pervasive, extensive use of the key AI technologies, which are LLMs and AI vectors. It also has many new and improved AI capabilities. It is also a long-term support release that replaces Oracle Database 23 AI. We are also enhancing Oracle Database 19c that many of you may already have in production with AI-ready capabilities. But 26 AI is our AI native database. And the magic underlying this is the concept of the AI vector. Vector is actually very simple as a concept and incredibly powerful. Vectors are basically a sequence of numbers that represent the semantics or the meaning of complex objects, such as documents or images or even relational data. They're produced by deep learning models, which can be invoked directly with an Oracle database. So you can take your image or your picture or video or your sound file or a relational document and produce a vector from it. Now, why is this important? This is because if you look at what databases have done traditionally, they traditionally analyze and search for data by values. Like finding the total sales for each product, it's a simple job for a database, easy, no problem at all. What vectors let you now do is to search for data that is semantically similar. Because, very simply, vectors for more similar data are closer together. And this allows you very easily to store vectors and search for closer vectors to find similar products. So you can see from this picture, the apple and the pear are similar and different from a plushy tiger toy. That's easy to do using vector search now. We have added sophisticated vector indexes. I could spend the entire hour describing them to you, but I won't today. But suffice it to say, they allow you to do vector search in milliseconds. We have in-memory graph indexes for the fastest performance on in-memory data that fits in memory, or partition vector indexes that extend to data of unlimited size. So vector indexes give you vector search in milliseconds. Now, one important thing to note is for business applications, which most of you are interested in, you need business data as well as vector data to answer questions. It's not just vectors. You need to use both so that AI can make informed decisions on business data, which means you have to combine that value-based search I mentioned at the beginning with vector search. And this is made very simple using Oracle AI Database. So a simple question like, does my dental plan cover braces for my 19-year-old child? That question was first vectorized and then used to search for similar documents, but only for plans that the user is enrolled in. There's no point showing the user plans they're not enrolled for. And then once you have that, you can return those documents as results of that search. And this is a very simple SQL statement that does exactly that. And SQL is a very powerful language. We didn't need to make any changes to the actual language to support vector search. This returns the top 5 matching plan documents for the user that match the user's question. And this search runs in milliseconds, so you can run this both for transactional workloads and for analytic workloads. We have unified vector search with not just relational data, but Oracle Database supports many kinds of data, and you can combine searches on text, spatial, XML, JSON, etc., with vector search without any problems. Now, vector search, one of the big use cases is for something we call RAG, Retrieval Augmented Generation. The relevant documents you found for the user, the plan documents, you can send those to a large language model to answer the actual question, because the vector search doesn't answer the question, just gives the matching documents. You can then call the LLM with the matching documents to say, hey, tell me exactly if there is a plan that would give my child coverage for braces if my child is 19 years old. That's the way RAG works. It's augmented with private knowledge found during vector search. I wanted to show you this quickly. I don't want to give you a SQL tutorial here. I know there's not enough time for that. But you can run all of RAG in a single SQL statement. It's pretty remarkable. And I've tried this myself, and I know this works. You first basically vectorize your question. Then you find the matching documents all using SQL, using vector search. Then you construct an LLM prompt in the same query. It's pretty impressive to me that SQL has this beautiful composable language that you can use to generate multi-step workflows. And then you can call the LLM with that prompt and get the response back, again using SQL. So again, don't worry about the detailed SQL statement syntax, but the point to show is that you can do all of RAG in a very simple way without writing any actual code. Of course, RAG is no longer sufficient, just vanilla RAG. You have to use AI agents to really get responses for complex scenarios. And AI agents use multi-step workflows to analyze data and to get data back from LLMs. And they use tools to take actions. Again, I'm not going to give an agent deep dive. I think every talk in this conference has some agentic components. But AI agents are the way to get basically beyond simple RAG. And one of the things we've done is to make sure Oracle Database works with agentic frameworks in all the major hyperscalers and all the major agentic development frameworks. We are also making it easy to integrate agentic AI with Oracle Database workloads. We have something called Select AI Agent. That's a query interface to agents. We are almost released a private agent factory if you want to build agents in your private ecosystems. And we're offering the ability to use MCP to interact directly with Oracle Database. So all of these things are available or will be available very shortly. By making Oracle SQL available as an MCP server, it gives Claude or other LLMs direct access to the database to run agentic processing with. And with this capability, you can integrate with something like Claude Desktop and simply chat with the database like a backend information repository. And Claude can run very sophisticated searches for you. This is a very simple example I'm showing here, but you can actually ask it to create reports, make predictions, generate summaries, etc., using this capability. One important thing that is required in this new world to succeed in AI is you have to be able to describe your data in a way that AI and humans can understand. Most enterprise apps, for anybody who's actually seen an enterprise schema, are incomprehensible to the end user. They have table names that are machine-generated, column names that are cryptic, and if a human being can't understand a schema, neither can AI. So we've added something called annotations that allow you to add additional context for schema elements without making schema changes. So you can say, for instance, that column that's called PN, which is meaningless to me and to most AI by itself, is actually a phone number. This gives LLMs more information with which they can generate the right SQL. And this is available both in our AI database as well as in the 19C database. In fact, annotating data is going to become the new way you tune SQL. Tuning SQL in the past required you to be an optimizer expert. Now, SQL tuning really for AI requires explaining the data to LLM so that they can understand how to make the best use of the data. Okay. Agentic AI is not, it's of course very powerful. And again, I could spend all day on this as well. It can combine data from multiple sources. You don't have to be limited just to database resident data with the agentic frameworks we have. If I have a question like, what is our share of the product, a certain product compared to the market, that can actually use database resident data and combine it with information found from the web, where there's a variety of data sources that it can consult. So all of this can be done using agentic AI, whether you build it with Oracle Database or use external frameworks to build them. Also, we're working on making agentic assistance available for Oracle Database users, because Oracle Database is a sophisticated product, and managing it requires expertise. We're trying to make it easy by providing management assistance, security assistance, knowledge assistance, etc., that help database administrators and end users get more productive use of the Oracle Database assets. And each agent is built using a different strategy for data and AI interactions to get the best outcomes. But these are all being built, again, using our own AI agentic frameworks. OK, now, one really important thing in Oracle Database is we've always been about being mission critical. That's why we run the largest banks in the world and in India. And because of this, our AI capabilities also benefit. So our vector database supports benefits from disaster recovery, transaction security that the dedicated vector databases do not have because they're new, they're still in very early stage development in most cases. This stuff was built over decades. And on day one, we have the full mission-critical support of Oracle's infrastructure in providing all of these capabilities without having to reinvent anything. So our vector support automatically gets parallelization and scale out and DR, etc. Again, I can spend all day on this slide telling you all about the different AI features we have, but I think Indradeep will not be happy, and I want to keep him as a friend after this. It's actually interesting. Vasu, I, and Indradeep are both from the same IIT, both around the same time frame, so I think we want to be nice to each other. That's one of my goals. I don't want to run into his time slot. But there's a ton of stuff in Oracle AI database to do with vectors and AI in general. But let me move on to something else beyond just database-centric concepts. Let's talk about integrating AI for data with app dev. Now, what does that mean for enterprise apps? All of us want this to be the future or the present. We want to tell AI, I want an app to do X, and I want AI to produce the app for me, right? Now, how realistic is this? We've all seen videos of miraculous AI app generation capabilities. Amazing, right? Much faster than human beings. There is a problem for enterprise applications because enterprises can only deploy applications that they can really trust to be secure, correct, and dependable. You can tell AI anything you want. AI is like a very intelligent teenager, I think. Extremely intelligent teenager who knows everything and always has an answer, never thinks it's wrong, but doesn't always follow the instructions given to it. You really can't run core banking with an app like that. It's not possible, right? You can sort of help a little bit adding guardrails, but guardrails aren't sufficient. They're after the fact. I call it, you need hard rails. You need like rail tracks that the AI cannot deviate from if you want to trust the outcome of AI. And we refer to these technologies and these techniques as generative development or GenDev. And again, this is not Oracle database specific. This is a general concept we're trying to make mainstream. It's really common sense that you need to engineer trust into the system. You can't do it after the fact. You can't take untrusted output and then try to trust it. It doesn't work. And the important thing is GenDev requires the output of AI to be verifiable. If it is not, the enterprise cannot trust it. If you give me 20,000 lines of Python or JavaScript code, I can't tell if it's correct or wrong. It's impossible. If you give me 50 lines of SQL, I can do a better job. We're working on something called an open application specification language, which is also solution-centric, that is human verifiable. So GenDev's goal is to produce these intermediate languages which are more solution-centric and easier for people to actually comprehend. That's the philosophy of GenDev. Now, again, understandability is good, but it isn't sufficient either by itself, because there's additional risks that AI introduces at the data level and the app level that need to be mitigated. Unfortunately, I won't have time to go through this in detail, but let me give you a quick tour of these problems and a solution outline. So let's talk about data risks from AI. What can AI do wrong? Or for that matter, even a human being. If I just let humans write arbitrary SQL, what could go wrong? They could break correctness. They could break data consistency. They could break the evolvability of data by exposing the underlying formats to the application, which is a very bad idea. If you expose the table structure to the end app, then you're stuck with that table structure without making significant app changes. Most importantly, you can break data privacy by leaking data you should not leak. There is a great technology in Database 26 AI, which I'm very proud of, but again, I don't have time to go into it today. It is called JSON relational duality. This is essential to prevent data risks for AI. What JSON relational duality does, it takes a very complex relational schema and produces updatable duality views that manifest the data in terms of JSON documents and JSON objects. So a purchase order will look like a purchase order document, a simple JSON document, but underneath it could be spread across many tables. This ensures consistency. It validates all the business logic required when you do reads and writes. And most importantly, the underlying table structure is not exposed to the application. So this gives you like an API that is guaranteed to be correct. And this is key for trusting AI-generated solutions. You can look up JSON duality online. There's lots of literature on it. But it's a foundational technology for GenDev. Privacy is a big deal. I don't have to tell you, all of you this. You all know this. If you divulge private data, you can go to jail. It's like really risky if you're dealing with corporate enterprise data, especially things like finance or healthcare. You can't divulge private data. And if you implement privacy in the app, there's a major problem with this. The problem is, again, you can tell AI the rules for privacy. Again, it may not follow the rules. And if the AI is given direct database access, it'll bypass all the app tier rules. So app privacy doesn't work in the age of AI anymore. The only way to do this correctly is to implement privacy rules inside the database. So you have to lock the doors inside of your house, for instance, to prevent movements that you don't want to authorize. You can't just tell people, don't go here, don't go there. You have to actually put the locks at the data source. And once you've done that, AI has to follow those rules. If AI generates some rogue SQL, that rogue SQL can't see unauthorized data because data is restricted from use. This is something called full stack data security in Oracle database. This is something you need, again, to be able to trust AI solutions. Okay? Now let's talk about, very quickly, how you minimize application-level risks by AI. Again, LLMs, I don't have to belabor this point. There's many things that can go wrong with LLM-generated code. You can be malicious, you can just be incorrect, or you can hallucinate. All of these things can go wrong. So what we want to do with GenDev is to use LLMs in a restricted sense, not in a free-form sense, to author arbitrary code. We want to restrict the usage, the results, and be able to validate why the output was a certain way. That's very important. And we have something called trusted answer search as an example of this, where a person wants to search for reports in a database. First of all, the search space is bounded, and the answer is going to be one of the reports in the database. So it uses vector search, not LLMs, to actually find the right report and to populate the report input fields. The LLM is not in the picture in this search. You can use LLMs to generate the report and to basically guide the report content, but the search is done deterministically through vector search. That's an example of using LLMs in the right way. We're not using it to create creative answers here. Very simple. You take a question, I have 50 reports, it'll give me one of the reports to run. The worst thing I might get is the wrong report, but I won't get some random answer completely. I don't know if any of you here use Oracle Apex. It's a visual IDE for generating application code, very popular. Many applications use Apex today. Apex allows you to use LLMs, again, in a limited sense, where given an end-user question, you can map it to a report and then apply filters, groupings, etc., that the user can verify. So again, it's not arbitrary. The outputs are restricted to a set of reports. You can't ask it the meaning of life. It won't answer it. It'll only give you one of the reports in Apex and then try to populate the fields in Apex so that you get the right report drill down. So it's an example, again, of using LLMs in a constrained sense. So I talked about reports, but you can also use AI to generate full application. That's the really interesting part. Again, lack of time, I'm going to have to speed through this quickly. We are working on something called an open application specification language, which basically describes what the application should do, but not how to actually do it. So LLMs can now generate this, and I can then say, yes, this is what I wanted. Once I sign off, OpenAppSpec can be used to generate the actual Apex screens deterministically. So again, it's like SQL. It's much simpler than Python or JavaScript code, and users can verify it. It's much more compact. So in that sense, it's a better fit for you for AI-powered development. So this is an example. Just again, in the interest of time, I'm mindful of the timer here, although I think I have a few more minutes left, though. Simple example, it shows you that I want a report that does sales over time, and I want the report to be of this particular style, and this is a SQL query. So this is something an end user can actually verify. And then from that, you can generate that corresponding Apex screen that tells you what the actual summary sales was. Does this make sense? So it's, again, GenDev. The output on the left is the output of the LLM. And this, even I could verify, but there's no code there. It's a simple description of the report. And then from that, you can say, deploy this and create the report screen in Apex. So that's an example of GenDev put to use. Very quickly, since I'm running out of time, do I have a few minutes left, or am I really at the end of the hour? I have a few minutes. OK, so then maybe I can slow down a bit in that case. OK, open standards. This is very, very important. One thing is AI developers are different from traditional application developers. And so we've recognized that, and we felt open standards are paramount in allowing Oracle database to be used for data-centric AI workloads. So one of the goals we have is to support all the leading AI models, all the leading frameworks. We call ourselves AI secularists. You can use Gemini, Claude, ChatGPT, no problem. We don't restrict LLM usage. You can use your AI frameworks of choice. We have adapters from all of these to call into Oracle database. We also have a private AI services container we're delivering very soon, where if you are a sensitive customer and don't want to ship data to a third-party LLM, you can deploy this container with a private instance of Llama, for instance, that you can communicate with using REST calls to avoid sharing data with third-party services. So again, full flexibility, cloud-hosted solutions, on-premises solutions, private clouds, it's entirely your choice. And Oracle database basically runs everywhere, which means Oracle AI for data is also available everywhere. We run on all the major hyperscalers. We have multi-cloud integration with Azure, AWS, and GCP. Many of our large customers deploy what we call cloud at customer, which is a cloud running within the data center premise of the customer, but is managed like a public cloud. And this runs on state-of-the-art Exadata hardware that gives it the best database performance. And of course, many customers just have gigantic fleets of Oracle installations running on their own privately managed infrastructure. And we support that as well with Exadata and the Oracle database appliance. So ideally, this means that you can take AI for data and run it in any environment. And many customers are going through a cloud transition themselves, so they can begin on-premises and then move to the cloud as they're ready, when they're ready to move to the cloud. So we support any stage of cloud evolution for customers. I think I actually covered everything I planned to cover for the most part. I only had to skip a couple of slides, so it's good. I'm glad I got the extra time with Vasu. See, Vasu is a good friend. This is what IIT is all about. It's all about fraternity and friendship. So I want to give Indradeep a few more minutes, too. So let me wrap up very quickly. Again, to summarize, you have to really strive to be an AI leader. If you strive to be an AI follower, you will lose. There's simply no way to do that. You have to be ahead of your competition. You need to use AI to deliver breakthrough insights, innovations, and productivity. And you've got to do it before your competitors do. Again, so don't wait. Don't wait. AI projects, yes, there's talk about AI projects failing. Don't pay attention to that. That failure measurement, by the way, had a very high bar. And projects take time to prove themselves. But every time I've seen AI projects being done with Oracle AI for data, they have succeeded. It's taken time sometimes. But they have succeeded. So don't give up and keep pushing on the AI journey. And with that, I think I'd like to wrap up. Thank you very much for your time. Thank you for attending.
Well, thank you, Mr. Larry, for that wonderful, insightful
Thank you.
session. Your perspective on integrating AI directly into mission-critical data system is highly relevant and actionable. Thank you so much.
Thank you. Thank you.
And to present the token of appreciation, I take this opportunity and invite the Chief Legal Officer, L&T Finance. Please welcome on the stage
Thank you.
Ms. Aparna Rawat.
Thank you.
Welcome, ma'am.
Thank you. Thank you. Thank you. Thank you. Thank you. We have to work together.